How's it going, everybody? Today we're going to be talking about electrostatics, and to understand a little bit about electrostatics we need to go into the structure of an atom. So I'm going to go ahead and draw an atom and let's talk about it a little bit. So where is most of the mass held in an atom?
In the nucleus. The protons and the neutrons together are the only ones that have significant mass. So all the mass comes from the nucleus.
Okay, so the nucleus is in the center, right?
Right.
So the protons, what exactly makes up the nucleus?
We got protons, and they have a positive charge.
And we have, what else is in there?
We have neutrons, which don't have any charge at all. Neutrons are neutral, but they're about the same size.
Okay, and then we have electrons, and electrons, they don't go inside of the actual nucleus, but they go and they travel around it in the electron cloud. So,
And they are teeny, 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 tiny.
little bitty guys.
They have some mass, but it's really not enough to really count for anything. So.
And they have a negative charge, correct?
Right. That's right.
So when we talk about electric charges, there are two kinds of electric charges. There's a positive and a negative. So what kind of so what do they do exactly?
Well, the positive charge comes from the protons, all right, and the negative charge comes from the electrons. Now, the protons don't move from the atom. They don't move from the nucleus, but the electrons do. Electrons can travel around. They can be shared between atoms, and that's how charge is carried from one atom to another. Electric charge, like electricity, is carried by flowing electrons. They are moving around from one object to another.
Okay, so if we have so when they do that, do they repel? Do they attract? Is there a difference between them?
Well, like charges repel. So if you have something that's got a mostly positive charge and another thing that's got a mostly positive charge, they are going to repel each other. It's like trying to put the two north poles of the magnet together. They repel each other. It's not going to work.
Okay, so if we have, so you said two like charges repel. So if I have two positive charges, they're going to repel?
Yep.
And if I have two negative charges, they're going to repel?
Yes.
So you're saying that if I have a positive and a negative, then they're going to attract?
Yep, that's right. Positive and negative charges attract each other.
So they would be going toward each other?
Yep.
For many, many years, there were no real choices in spraying technology. A solution emitted from a conventional hydraulic sprayer covers only the top or front of the object, but leaves much of the target uncoated, especially on the back or underneath side. Electrostatic spraying systems has changed that. Now you can coat the entire targeted object. Watch this apple duster demonstration and see for yourself. The first apple will be sprayed with a conventional spray technique without an electrostatic charge. Now we apply the electrostatic charge to the sprayer and coat the second apple. Which would you prefer? Whether spraying for insects, mold, bacteria, or germs, only electrostatic spraying systems gives you full coverage.
Insulators prevent charge.
So the stuff that goes around the outside wires is going to be the insulators. That way, whenever we touch it, we don't shock ourselves, correct?
Yeah, exactly.
Okay, and what about semiconductors? What are semiconductors?
Semiconductors are materials that are kind of in the middle. They allow some charge, but not very much. Examples of that are silicon, which is inside of your inside of computer chips and things. They allow some charge, but not a whole lot.
Okay, so that's between the conductor and insulator?
Yeah, it's right in the middle. Insulators do not allow electrons to move freely through it. So whenever you plug in your phone, inside of your phone's cord, your phone charger's cord, is a metal. It's a conductor that allows electrons to flow through it. I mean, that's why it works well for an electrical cord. If it wasn't metal, if it was like plastic or wood or something, the electrons wouldn't be able to flow through it, and your phone wouldn't charge. So conductors are materials we use to charge things.
What about superconductors?
Superconductors are really cool. They allow a high amount of charge, so much charge to flow through them, and that charge doesn't change. Whenever you heat up most conductors, most metal materials, the charge will decrease, it'll go down. They won't allow as much charge through them. But superconductors will never change. You can heat them up, you can cool them down. They will always allow a lot of charge to flow through them, and they're very rare.
And won't change, and they won't fluctuate with temperature, right?
Right.
So let's go ahead and talk about a few other things. How do we charge things? So let's go ahead and talk about things that we charge with contact. Now, what exactly happens whenever we charge things through contact?
Well, you take a material that has charge and you put it next to either a conductor or an insulator, either one. They touch each other, and that charge will move the electrons around inside of that conductor or that insulator. Things that you charge by contact are like your phone. Whenever you plug in directly to the electrical outlet, that's charging through contact. Your conductors and your insulators are touching the electrical charge.
Okay, so two objects rub together, and electrons are transferred from one object to the next.
Yeah.
All right. What about induction? What is induction?
Induction can only happen with conductors. You can't charge insulators through induction. That's where they don't quite touch. You just bring the charged material very close to the conductor, and the electrons still move around and charge flows.
Okay. So I've heard about induction, and I've heard about polarization. Now, what is the difference between induction and polarization?
Induction can only happen between a charged object and a conductor. Polarization can only happen between a charged object and an insulator. That is when inside the insulator, some electrons move around. They move to one side of the object closest to where the charged object is. And then the protons are left on the other side. And so this can happen with paper. Sometimes when it's really dry outside, your paper will stick to you or stick to some other metal object. Paper is an insulator, but some of the electrons move around a little bit, so you kind of experience that electrostatic charge still.
Okay, so who was the person who really started to take a look at electrostatics and electricity?
Benjamin Franklin.
And he stated that he stated the law of conservation of
Electrical charge.
right, and that is that electrical charge cannot be created or destroyed. However, it can be transferred from one object to the next, and that's the same with electrical charge, mass, energy, and momentum.
Mm-hmm.
So, go ahead.
Oh, sorry. Well, basically, what that means is that whatever charge is lost by one object will be gained by another object, but the electrical charge will never just disappear or somehow be created. It can move around, but it'll always be there. It's never lost or destroyed.
There are three ways that objects can acquire a net charge. What we see here is an example of charging by friction. Electrons are being transferred by friction when one material rubs against another. Because electrons are lost by one material and gained by the other, the objects now have opposite charges and attract. Charging by induction can be shown using two insulated metal spheres. Uncharged insulated metal spheres touching each other form a single non-charged conductor. When a negatively charged rod is held near one sphere, electrons in the metal are repelled by the rod. Excess negative charges move to the other sphere, leaving the first sphere with an excess positive charge. The charge on the spheres has been redistributed or induced. When the spheres are separated and the rod removed, the spheres are charged equally and oppositely. They have been charged by induction, which is the charging of an object without direct contact. Charging by induction is not restricted to conductors. Charge polarization can occur in insulators that are near a charged object. When a charged rod is brought near an insulator, there are no free electrons to migrate throughout the insulating material. Instead, there is a rearrangement of the positions of charges within the atoms and molecules themselves. One side of the atom or molecule is induced to be slightly more positive or negative than the opposite side. The atom or molecule is said to be electrically polarized. When an external negative charge is brought closer from the left, the charges within a neutral atom or molecule rearrange. All the atoms or molecules near the surface of the insulator become electrically polarized.
All right, well, here's some final things to remember. Electric charge is always going to be conserved. Conductors and insulators can be charged by contact, and we talked about that a minute ago. Conductors can be charged by induction, and insulators can have a surface charge due to polarization. All right, well, that's it for us, guys. We'll see y'all next time.